The last topic we're going to cover in our rational functions unit has to do with partial fraction decomposition. So our essential question today is, how do I find a partial fraction decomposition for a rational expression? Be sure to set your paper up in Cornell format. Leave space for questions and summaries. So first, let's talk about what does it mean to decompose a rational expression. So partial fraction decomposition is just the process of taking an expression and breaking it down into the sum of two or more simpler rational expressions. So it's like the reverse of an addition problem with rational expressions. I'm giving you the answer and I'm asking you what has to be added together to get that fraction. So we're going backwards. Instead of adding two fractions together to find the answer, you've got the answer, you have to find the fractions. Okay, so our first step anytime we're doing decomposition of rational functions is to factor the denominator, not the numerator, just the denominator. So x squared minus x minus 6 will factor to x times x for x squared. We need to multiply to get negative 6 and add up to negative 1. So that would be a minus 3 and a plus 2. So my factors are x minus 3 and x plus 2. Now, we're going to use those as our denominators, and it doesn't matter what order you write them in. So I'm going to put an x plus 2 on the first fraction, x minus 3 on the second. If you had it switched, it would not matter because we would still get the right numbers just in the opposite order. So now we've got our denominators taken care of. We need to figure out what goes on the top. Okay? So our second step is going to be to set the problem up as a sum of factors, and since we don't know what those numerators are, we're going to use some constants. So that's what the capital A and B stand for, some number or something that goes in the numerator of that fraction. Okay, for step 3, we need a way to solve and find out what A and B equal. So what we're going to do is we're going to find the least common denominator, and we're going to multiply everything in the equation by that least common denominator. And it's going to be your factors multiplied together. So we're going to do times x plus 2 and x minus 3 to each term. Now, let's see what we can cancel out and make this a simpler equation. The point of doing this is to get rid of the fraction so that we just have a simple equation we can solve. Okay, now remember, the x plus 2x minus 3 came from factoring this first denominator. So this whole denominator is going to cancel out on your original side of the equation, which just leaves us with x plus 7. On this first fraction on the right side, the x plus 2's will cancel, and that leaves me with an a times x minus 3 plus, on the second fraction, the x minus 3's will cancel, so b times x plus 2. So all I did was get rid of the fractions by multiplying through by the least common denominator. So now I have an equation that has no fractions, but I still have lots of variables. So how am I going to solve? Remember, we're trying to find what A and B equal. Okay, so here's the equation, and what we're going to do is we're going to use something called convenient values of x to figure out what A and B are. Convenient values are the numbers that will make these factors equal to 0. So if I have an x minus 3, then I'm going to let x equal 3, because 3 minus 3 will give me a 0, and that'll get rid of my a. Okay? I can also use a negative 2, because negative 2 plus 2 will give me a 0 there to get rid of my b. Now I'm not going to do these at the same time. I'm going to do one at a time, but those are the two convenient values. So I'm going to first let x equal 3. So everywhere in that equation that there's an x, I'm going to substitute a 3. So 3 plus 7 equals a times 3 minus 3 plus b times 3 plus 2. 3 plus 7 is 10. The a is going to be times 0, so if I have 0a, I don't have to worry about it anymore. And then I've got a 5b. Now I just have a very simple equation. I divide both sides by 5, and I get b is equal to 2. So now I found out what b is, but I still need to know what a is. So let's use the other convenient value, which we said was -2. And I'm going to go back to my original equation, and everywhere there was an x, I'm going to put in -2. So -2 plus 7, a times -2 minus 3 plus b times -2 plus 2. And again, the b times 0, I don't have to use that anymore because I don't have anything there. Okay, -2 plus 7 is 5, and then I've got -5a. I divide both sides by -5, and I come out with a equals -1. So the constants that I needed were 2 and -1. Okay, remember, convenient values are numbers that will make the factors equal to 0. So if x minus 4 was a factor in my equation, then 4 would be a convenient value because 4 minus 4 is 0. So we're trying to zero out one factor at a time to figure out what those constants equal. Okay, now last step is we go back and we substitute those constant values into the equation that we started with. This was my a value, this was my b value. Okay, so if you look back at step 2 where you have the setup of the problem, all I did was put in the number we got for A and the number we got for B. And this is the partial fraction decomposition. If I took those two fractions on the right side, got a common denominator and added them together, the answer would be the fraction that I started with, the x plus 7 over x squared minus x minus 6. Okay, now I'd like you to pause the video and see how far you can get, use your steps, and see how far you can work this one, and then turn it back on when you get stuck or when you're ready to check. Remember that your first step is to factor the denominator, and in this case, the denominator has a common factor of x, so x times x minus 14. That doesn't factor any further, so I'm going to set up my fractions. Okay, x is one of my denominators. X minus 14 is the other denominator. And then I don't know what goes on the top yet, so we're going to use an A and a B. Okay, so here's the setup. That's step 1 and step 2. We factored and we set up our equation. Okay, step 3, we're going to multiply everything times the common denominator, which is x times x minus 14. So every fraction times the common denominator. See what cancels. So on the left side of the equation, the whole denominator cancels because that's where we got our common denominator from. So I've got 7 equals. On this first fraction on the right side, the x's will cancel. So I have a times x minus 14 plus, on the second one, the x minus 14's cancel. So I just have b times x. Okay, now I've gotten rid of my fractions, but I still need to solve for a and b. So I'm going to use my convenient values. And the convenient values in this case would be 14, because x minus 14 equals 0 would give me an x equals 14. And over here by the b, I just have an x, so I'm going to let x equals 0 be the convenient value there. So I'm going to substitute these in one at a time. So if I let x equal 14, I'm going to substitute 14 everywhere there's an x. So I have 7 equals a times 14 minus 14 plus b times 14. Okay, 14 minus 14 times a cancels out. So now I have 7 equals 14b. And if I divide both sides by 14, I come out with b equals 1/2. 7 over 14 reduces. Okay, now to get, that's one of my constants. I need the other one, so I'm going to let x equal 0. Okay, so now I'm going to put a 0 everywhere I see an x. So 7 equals a times 0 minus 14 plus b times 0. Well, b times 0 cancels itself out. So now I have 7 equals -14 times a. If I divide both sides by negative 14, I'm going to come out with a equals negative 1/2. Now, I go back and I substitute into my original setup. So my original equation was 7 over x squared minus 14x equal to, I had a over x. Well, a is a fraction, and I don't want to write the negative 1/2 over x. That's not a good way to write that. So what we're going to do is we're going to write it as negative 1 over 2x. The denominator is actually going to end up in the denominator with the variable. Okay, plus the second fraction was b over x minus 14. And again, b was a fraction. It was 1/2. But I'm not going to write 1/2 over x minus 14. So the 2 is going to end up in the denominator. So I want to use parentheses because 2 times x minus 14 is different than 2x minus 14. So our partial fraction decomposition is this equation. Now if you want to check yourself, use your addition and add the two fractions that we just got together and see if it reduces to 7 over x squared minus 14x. Okay, in this video we only looked at linear factors. Tomorrow we will look at repeated factors, repeated linear factors, or factors that aren't linear. If it's not just x minus 14 or x, if there's an x squared. Be sure to put a question mark by anything that you're confused on and ask when you come to class.